started, bro.
Yeah, thank you. Okay, good evening all. Uh, as a continuation for our Java learning, so today is the topic collection framework. So we have completed like multi-threading and we are starting with collection framework from today. Let's see it. Are you guys able to view my screen?
Yes, sir.
Sorry. Hello, are you guys able to view my screen?
Yeah, bro.
Yeah, thank you.
Yeah,
Okay.
bro. Wow.
Yes. So collection. Okay. Collection, the naming itself says that it is a container object. Okay. That represents a group of object, often referred to as elements. So whatever we call like most of the things like no elements, even in case of array also we'll tell like array elements. Okay. Similarly, like collection elements. So it is nothing but there will be group of objects. Okay. The Java collection framework supports three types of collections. Okay, one is sets, lists, and maps. So these are the high level, like what and all available in collection framework in Java. So if you take for this arrays and collections, so if you see the description wise, even array is also like collection of objects. So which are there for similar type. So and here we are saying collection is also same. Collection of objects. Okay. So what is the difference is? So if you see the high level, both works at the same level. Okay. So that is also stores the objects. This is also stores the objects. Okay. And that is also like index base. Here also you can find out like some index base and traversing. I mean the array like we can traverse the array and we can able to fetch each element, and if you want to do some manipulations we can do that. So that kind of provision is available in arrays. Similarly, even in the collection also, like we are having like we can traverse through the collection and we can do some manipulations on the collection of elements. So these are all the things can be done. So the major difference here is arrays of fixed size. Okay. We have seen in the arrays topic. So while creating the array itself, like no, either by listing the number of elements, we will define the size, or else first we will declare the size, then we will add the elements. So the size is fixed. Okay. Let's take I have given the size as 5. Now I got the requirement to increase that to more than 5. So in arrays, there is no provision actually. You have to create another array with a bigger size and you copy elements from that array to this array. So that is one of the options available. But in case of the collection, the size is dynamic. Okay. So there will be some initial capacity will be there. And once you reach that initial limit, so automatically JVM expands it. Okay. That is called this as a dynamic. Also in this, like in case of the arrays, so you cannot do any sorting and all such kind of things by default. So by applying some logics and all like we can do, but here, so we can, there is a such kind of facility like while inserting itself. So which order you want. So if it is a different order, like you can define it. And if it's a sorting or ascending or descending order. So all these kind of facilities are available in arrays. So that is a major difference between this and that. Also, inserting the elements like majorly like no, it will go in the sequential. So 0th index, first index, second index, it will go in something like that. Or else like if you know the index in that particular index, this element needs to be inserted, that can be performed there. Okay. So let's see for the hierarchy of the collections. Okay. If you see the list set or the sub interface of the collection. So there will be one interface is there, like which is the very topmost actually. Okay. So this is the hierarchy starts with the collection interface. So this is the one collection as interface. From that you can see there are the two other interfaces. One is a set, another is a list. Okay. From the list, there is an abstract list. So from this abstract list, we can see vector is a class, and that is also stack is also there. So which internal uses the stack actually, and array list. And if you see abstract sequential list, there is a one more class is there. From there is a called like linked list. So these are all the things. If you see high level, list implemented classes in Java are vector, array list, linked list, and stack. So these are all the 4 core classes actually. So in case of the list, okay, that's where here it is telling like concrete classes. So this complete line represents the concrete class. Concrete class means, so there is no any abstraction. So everything means it's a fully implemented class. So that we'll call as concrete. So, but this line it is representing as abstract classes. So abstract classes means, so it will be having like some implementation and some abstraction. Okay. And these are all the one. There is a complete set of interfaces. So this is for the list. When it comes for the set, so we are having set, abstract set, that's abstract class. From there, hash set and linked hash set is there. Okay. And from the set itself, we are having the sorted set, another interface. And there is a tree set implementation, like which is providing the implementation for sorted set. Okay. So this is just the hierarchy. Just try to see that. We'll go by each interface and each class theoretically and programmatically. Okay. So this is the representation of hierarchy of collection interface, which is set and list implementation. Okay. Now let's see for another one, which is there as a map. Okay. So map is different actually. It represents a group of objects. So each object is containing with a key value pair. So there will be key is there will be value is there. So in such kind of representation, we will go for map implementation in Java. So if you want to get the object, so by using the keys, so keys, we can take it as a primary keys actually. So it should be unique. So based on the key, I can get the complete object of it. So while putting also it's similar. So in case of the map, the interfaces are map and sorted map is there. And there is abstract map implementation. So that is abstract class. From there, hash map and linked hash map and also tree map. If you see for the set and map, these everything, the namings are same for each interface and abstract classes and concrete classes. The only thing is whereas the map is there is a set is there. So if you see here, set, sorted set. If you come here, map, sorted map. So from sorted map, there's a tree set, sorted set. So if you see tree map. Also like from set to abstract set is there. From abstract set, hash set, linked hash set. So from map, abstract map is there. From abstract map, hash map and linked hash map. So the structure remains the same for set and map. Okay. And even the features wise also many things are common. So we will see going forward. So this is the hierarchy of the collection framework in Java. So if you see list and set. Those are the one like which is handling single object. Okay. Single object level. So object of elements. So those are like direct objects. So map is the one. It is also collection of the object, but each object represent as a key value pair. Okay, there will be one key for that, and there is a value for that. So in such kind of requirements, we will go for the map. Okay. So as we mentioned, there's a collection interface. So it is having these many functions actually. So one is a add. So for adding the objects. So if we have all in a single shot and also clear. So and contents is the one. So if you want to check for some particular object, so means whether it is present or not, something like this, you can get this. So if you see the description also next to it, clear means removes all elements from this collection, and the contents means checks if it is present or not. Okay, so there is a some list is there. I want to know. I know the object. Okay, so I would like to check that whether this object is present or not. So directly by calling the contents method, I can get to know. So if it is containing, it will return the true. So in case of array, what we were doing is we were going each element by element and we were comparing it. Okay, this is containing or not. But in case of the collection, directly with a single function call, we can get to know. And also contains all. So I have like collection of objects. Let's say 5 objects are there. I want to check there is a big collection is there. Like I want to check all these elements are present in the top collection or not. So in such cases, we'll go for contains all. So this is a equals. So whether equals is the same actually. So comparing between two objects and hash code. So hash code is the one like no, it returns hash code for that particular collection. So another is empty. Is empty means whether there are elements are there or not. So in such cases, we will use the is empty. So another is iterator. So iterator is the one. So if you want to traverse through the collection interface or collection of elements, that is where we will use the iterator in Java. So it means, so I want to fetch all elements from the list. So then that case, so I will go for iterator. So this iterator common for even in the list of map elements. So you want to traverse or you want to get all the list, all the elements from the map. So even in such cases also, we will use the iterator. Okay. Then remove. So if you want to remove the specific element, so you are having this remove function. Remove all means you are having 5 elements and you want to remove all those 5 elements in a single shot. So that's where like remove all. So on the size represents what is the size of the collection. And to array means if you are having the collection means list actually. So you want to convert that to the array. So in such cases, there's a to array function if you get called. So immediately there is an array will be created with that particular number of elements. Okay. And if you see the iterator I mentioned, right? So how it loops is this one has next. Has next means whether is there is a next element or not. That is the one. If it is having, then return the next element. So that is by calling the next function. And remove is the one. If you want to by chance, if you want to remove any of the element, you will use the remove. So this is a iterator and collection high level like root interface. So these are all the functions available in defaultly collection interface itself. Okay. So what we do is instead let's go for list first. Okay. So this is the one, the list interface. So what it do is it allow duplicate elements actually. To be stored in a collection, you need to use a list. So it's nothing but list of elements. But any collection of like no some objects, you can use the list. And also like with the list, like we can define the position also like, so allow the user to specify where the element is stored means you add at the starting or you add at the end. So or else you add like no before to some particular index. So all such kind of facilities are there supported by list. Okay. And the user can access the elements by index. Okay. Here there is index support is there in list. Also the search is very easy or very faster in list. Okay, because it implements the random search interface. That's why if I want to search, there is a 10 elements are there in my list. If I want to search for the particular element, so it gives a faster performance. We'll see all these things. Okay, list is the one which is implementing the collection interface. So we have seen the set of functions described for the collection interface. Okay, and list is also having some other functions. Okay, see add based on the index means I want to add this particular object at particular index of the array. This is backed by array, right? So that is where, like, so I mentioned, right? So I want index support is there in list actually. So if I want to add some particular object at 7th index or 10th index or 3rd index, so any kind of support, like we can go for this add function. So and also add all. So at the particular index, you add all these elements. So in that case, we'll go for this. And also getter. So if I based on the index base, you can go. So I want to know what is there in the 7th index. So it will return that particular object. Okay. So index of means like you are giving some object and you want to know the index of that particular object. So even that is also available. What is the last index of? So let's take, because it allows duplicates, right? So I want like some particular object. There are the duplicate entries are there for that. I want to know what is the last index of that, because there is multiple indexes, right? For the same thing. Let's take ABC is a string type I have taken. I have declared ABC, ABC, ABC list dot add. So it means list is having 5 objects. All objects content is same. So in such cases, I want to know like what is the last index of the particular object. So that gives the last index of function. And also is a list iterator. We have seen iterator before, right? So there is another iterator. There's a list iterator. So this is specific for list interface only. So what it will do is like from unidirectional, I mean bidirectional actually. So if you see general iterator is unidirectional, means only from starting element to end element it will go. But in case of the list iterator, even it will support the unidirection, I mean one direction, another direction also, means reverse also. So I want to start retrieving the elements from last index. So even that case also the list iterator works. So we will see all these examples going forward. And remove. So index based, like if I want to remove this one, and is also set. So if I want to set like no some particular element at the specified index, it will work. Sublist also is there. So there is a total list of 100 elements are there. And if I want to form sublist by taking like no 20 or 30 elements out, so in such cases, we will go for the sublist function. Okay. So this is nothing but similar to substring, right? From index to index. So it's a similar like even here sublist. So we have seen like list iterator, right? So what are the functions? So adding, see next index means whether next index is present or not. If it is available, then it is a next. The function will be there. Okay. And has previous. This is the one for the starting point. Has next, has previous. Okay. Means has next means whether next element is there or not. So has previous means is there a previous element or not. And search, then get the next index, get the previous index. So next index gives the current element, previous index gives in the reversing order. So previous, and we can set the value also for any particular object by using this. Even we can even add. If you see in the actual iterator, this add and set is not there, and also reverse direction is also not there. So these are all the different things compared with the iterator. So list iterator, it works only with the list interface, but all the regular iterator works with set, map, list, all these things. Okay, so that is the unidirectional. This is the bidirectional. So you can traverse from starting to end or from end to starting. So anything like we can do. So this is about list iterator. So now we'll see the core classes are like array list and linked list. Okay. So these are all the one concrete classes which are providing the implementation for the list interface. Okay. So these are the two facilities are available based on our requirement. We can choose like which one to choose. Okay. So if you want only the search, so means even adding insertion and deletion is a lesser and your search is the more. So in kind of such cases, we'll go for the array list. or else there is a requirement for you. There is a frequent insertion and deletions are there. In such cases, we'll go for the linked list because array list gives a better performance for the search functionality. Okay, and linked list is the one which gives a better functionality for the adding and deleting. Okay, so list can grow or shrink dynamically. Okay, that's what I mentioned, right? The size can grow or it can even reduce also. So that's why it's a dynamic. So, and if you comparatively with array is a fixed one. Okay, and generally like if you know everything, the size is very predefined and you don't get like any insertion deletions at the later case. In such cases, like better to go for array itself. But you are having like no insertions and deletions and you don't know the exact size of it. So in such cases, you will go for the list actually. Okay. So there is a one like linked list. So list and abstract sequential list. So then here is a one linked list. So this is having the functions called like add first. So if I want to add element at the first index, so in such case, I will use the add first function. So add last. So if I want to add element at the last, and also get first and get last, and remove first and remove last. These are all the additional advantages actually. So that's where I mentioned insertion and deletion. So linked list is the better choice. Okay, let's see as a examples now. See, we have seen two classes, right, within the list. Majorly, the concrete implementation is there in array list and linked list. So first, we will see example of array list. So what I have done, I have created the array list object. So this is the way we can create. There is a different set of constructors are there. So I have just used a default constructor. Okay, creating array list. So this is the one. This is the generics actually. So what type of objects it is holding. So during the declaration or creation of the object time itself, we should define like, so this is a collection, but what type of objects it will hold. So that is the type we are defining. So here I have created the array list object. So what I'm telling, so it is holding string type. So string object, list of string objects, it will be holding by this list interface or array list. So let's see, I'm adding the elements actually. So list that add, this is a string, right? So mango, apple, banana, grapes. So like this, I have added 4 elements actually to my array list. So this is where like the add functionality I have explained, right? So this is a function like, so like this, like we can perform all these things. So there's another one is traversing list through iterator. So I mentioned iterator, right? So iterator is equal list dot iterator. So set dot iterator, list dot iterator, map dot iterator. So this is the way we will create the iterator and list actually. So this is the default function which is available in the list interface. Okay, I've shown you sometime before, right? This is the one. So what is iterator is having has next means there is a next element or not. So if it is having, so till the time all elements, the next is the function which gives the actual next element. Okay. So if there is no next, then it will ends. So it is there in the while loop. Like this, I can fetch each and every element from the array list. So let me execute this one. See here. So what I've done, I have created one array list. Then I have added 4 objects to it. Okay. So then I'm traversing the list and I'm trying to fetch the element by element and I'm printing it. So I can able to see mango, apple, banana, grapes. So this is, it guarantees the order actually. So it's a ordered collection means whatever the order you inserted the elements, so in the same order the elements will be placed and fetched. So that's where it's a ordered collection. So you should remember that, like why I'm highlighting this ordered. So comparatively with other interfaces, right? So there are the other interfaces, those are not the ordered one. So let me write code for other functions. We are having like many other things, right? List dot contains. So I would like to check whether apple is present or not. If is contains. So another thing is system.out.println size. I would like to know is the size of this particular array list at this moment. Okay. And list dot remove. So what I'm doing, I'm removing the apple here. Okay. And now after removing the apple, again I will run the contains. So else block I'm keeping system.out.println apple is not present. Okay. Then again I will traverse through the iterator. Means I will print all the elements after removing my tier 1 because it will become the duplicate element. Yes. Let's execute now what happens. If you see here, first when I iterated through, I have 4 elements. Then what I'm checking whether apple is present or not. I'm checking yes, it is contains means it is already present. So then what I'm doing, I'm printing the size of the list. So how many elements are there? 1, 2, 3, 4. So there are only 4. The size is 4. Then what I'm doing, I'm removing the apple actually. Okay, I can do even this also. What I've done, I have deleted the apple by using the remove function. So after deleting, I'm traversing through the array list. So now I can see in the traversal only 3 elements. So then again, I'm checking for the presence of the apple. So contains. So apple is not present. And the size is 3 now because initially there were 4. I have deleted 1. So with that deletion, now it became like 3 elements. So like this. So what are the functions I have shown in the slide, right? So any kind of function like we can apply here. So getter, like let me get with some index base. List dot get of, see if you see, I have index base. So let me see first index, whatever the element is there, I would like to know. And list dot. So you can see like many of the functions here, contains all, ensure capacity equals for each get index of. So I would like to know index of the particular which one I will look for grapes because I don't know. I know the object name, but I don't know its index. So if I want to get to know the index of it, I can get to know with the object. Okay, let me add some debug message. Index is so that you can identify. Now, what are the other functions are there? Remove anyway we have seen. Okay. Size we have seen. Sort and all we will discuss in separate topic. Okay. 2 array. Yes. I think we covered almost. Okay. If you want to replace like all the things, that one retains all. If you want to retain like some particular things, you can use this. Wait notify is the common actually. Is empty or not? Let's check even this also. System.out.println list is empty. Else list is not empty. So what I do, I will call a clear. Okay. So after clearing it, I'm just checking. So like this, like, so these are all the straightforward actually. So we don't need to write complex code and all. So these are like straight away available many functions. So everything can be, we can apply actually. Yeah. If we see here, so Apple is not present and 3. We have seen all this. So what is the new code after that I have added? I get in the get first index. So what is their first index? Mango is a 0th index, banana is the first index. So it has given me banana. So what I'm checking, like index of grapes. So I want to know what is the index of the grapes. So that is giving 2, 0, 1, 2. So it is 2. So what I'm doing, whether list is empty or not, I'm checking. I'm checking the list is not empty. So then I have cleared the list here. So after clearing means removing all the elements. So making it as empty. So that is a clear function will do. So that's where I can see list is empty after clearing it. Okay. So this is about array list. The only one thing is, let's see, like duplicates it allows, right? Again, mango. List dot add of apple. See, if you see here, let me print. Okay. See here after printing mango, apple, banana, grapes, mango, apple. So it is giving me 6 actually. So that's where it allows the duplicates. Okay. Wherever in the collection like no does not allow duplicates, right? We will see in case of the setter map. So how it behaves. Okay. Is that clear about the array list? So we have covered like most of the functions. And now let's see for linked list. So I create the linked list object. It's most of things are very straightforward. Like, so if class A is there means I want to create object for class A. There at A of A equal new A, right? By calling the default constructor itself, we can create the object. So similarly, most of the all collections are having the default constructor. So the only then change is the generics. Means the type we have to define the type, like what type of objects it is holding. So that we need to tell. So remaining things are same. So here also I'm adding 4 elements. So and then I'm printing all these 4. Let's see. See here, Ravi, Vijay, Ravi, Ajay. So all like list interfaces classes are ordered. So that's why. So list is the ordered collection. So if you have requirement where like I want elements to be printed back in sequential or insertion order. So whatever the order I have inserted my elements, in the same way I should get back. So in such kind of requirements, you will go for the list interface. So within that, so if you want for better search, you will go for the array list. And if you are having like no more number of insertions and deletions, then you will go for linked list. So this linked list is nothing but backed by doubly linked list data structure. Okay. So let me see other elements, other functions of it. Array list, linked list dot add first. So linked list is having support, right? Let me see add first. So I want some element is there. I want to add this at first. Okay. So after adding, so al dot add last. So add last, like I am adding Bolu to the last. So after doing this two, I am printing again. Okay. Now remove is the common, like, but let's see what the different is. Remove first now. See here, you can get to know all the functions supported. So remove directly, you can remove, or like index base if you want to remove, or some particular object you want to delete, or remove all means some set of objects you want to delete, or else if you want to delete the first one or last one, and if you want to delete only the last occurrence. So because duplicates are present, right? So in such cases, you can use like anything. So let me do this. Remove. Let me delete the first element. Al dot remove last. Okay. So after this, again, I would like to print. What will be the content of it? ITR2, ITR2, ITR2. And everywhere, like, let me print the size of it. Question dot auto println size is al dot size. So this I will do in multiple places before insertion. After removal, anyway, we are done. After adding, this is their initial phase. Okay. And then what I do, I will clear everything. Oh, contents is also there, right? If al dot contents. So I would like to check whether this guy as I is present or not. Is present. So I would like to clear all the elements. Okay. So if al dot is empty. So after clearing everything, I'm checking. Yes, empty. So these are all the things like guys, like even if you see in the API, I can show you how to search and all, like array list in Java. So Java 8 specification. So this is from Oracle. See here, this is the class array list of with the generic type. So it is implemented the interfaces I mentioned, right? List interface it is, and also random access. Because of the random access interface, it is having the capability of randomly searching the elements. Okay. And let's see for constructor types and like everything is there. See, these are all the constructors. So one zero argument. And if I have some collection, from that collection to I want to convert to the array list. So in that such cases, we'll go for this. And here, like you will define the initial capacity. So if you won't define any capacity, JVM creates a section as a capacity. Once like you add like more than section elements, then it will double every time. So let's take section initially it had given, you have added section elements. And when you're trying to add the 70th element, it is not able to accommodate. So it got to know that. So the size means already reached. So what it will do? It will double the size. It will double the size and automatically it will copy all the elements actually. So another array it will get create internally and it will move all one array elements to the another array with the 32 size. That is where that's adding and delete is a like no it will not give the better performance actually. By chance, like if reaching the limit, what it has to do, it has to take the new array, then it has to copy all these existing array elements to the new array, then only it can able to perform the insertion. So in such cases, there is a delay actually. So for creating the new array with the new size and copying the existing array elements to the new array. So that's where like that is only the bottleneck for the array list. So say these are all the functions. Like if I want to add specific element in the array, and if I want to add in some particular index. So these are all the things actually. So you can get to know all these type of functions, and there is the documentation means description for each function. So like this, like you can call like straight away all these things. Okay. This is about linked list. So there is another is there is a vector. So vector is a very legacy class actually. Mine. So this is a type like creating a vector object. So here also same thing like vector.add because it is implementing the list interface, right? So whatever the functions available in the list interface, those are all applicable for the vector also. So by using add ABCD. So like this, like no, I can add all the elements actually. This is about the vector. So in the vector, like now everything is a synchronized actually. So let me open that. I can understand. Hello.
ಕಾಮು ಏನು ಮಂಡಿ ಬಿರಿಯಾನಿ ಅಂತ ಮಂಡಿ ಬಿರಿಯಾನಿ ಅಂತ ಮಾಮೂಲಿ
Okay. So this is the vector class, and you can see like constructors. So default constructor are from one. If you know like from list to vector, if you want to convert, so you can do all such kind of things. And capacity also same thing. So it's whatever is applicable to the list, it is also almost same. So if we say add function, so add all, add element. These are all the methods available in vector actually. So the iterator is also same. So whatever the iterator is there, so it will give all kind of like traversing the elements actually. That is almost like everything is same like for that vector and is. So if you see we have seen, right? That is in the multi-threading programming, like it will block like only one thread will execute. So other threads will be in the waiting state. So that is another difference actually for the vector. The examples are remains the same, like creating the object like vector.add, vector.remove. This iterator also remains the same. So these are all about list implementing classes in Java. So we have seen like location, specified location, add first, add all these things under vector and all these are like very old. So before to the collection framework, there were vector and stack were available. So after that, these are get like no, they have redesigned to fit for the collection. So that's where like they have inserted this list interface. So in case of the, see if you see the difference phase array list and the vector. So array list is a non-synchronized. So means all threads can work parallelly. So if you have a requirement that to have the requirement, the updates can happen or reads can happen by only one thread. So we don't want multi-threading environment. In such cases, the vector is a better option. And in case of the multi-threaded environment, vector is the wrong choice because it will give the very poor performance. Because if there are the 100 threads are there, 100 threads are trying to read some particular collection. So what vector will do? It will make sure only one thread will read at a time. So that's where like each thread, one thread it is taking 10 seconds. So for the 100 threads, 100 into 10 seconds. So it's kind of that much time will take. But in case of the other like array list or something, so by max of like 10 seconds only, all the threads can read the parallel and it can complete that particular task. So that is actually the first element, ensure capacity elements. So it is having like iterator and also it is having the enumeration. So through enumeration also, it can iterate the elements. So this is about like for the list actually. So for the set, we will see in next class. So for the comparison, let me go back. See, I just made like no on the comparison level. So what under level, so to make it like more clear. So this is on dynamic arrays to store its elements and maintains insertion order. So array list can carry duplicate elements also, and it is non-synchronized type. Okay. So in case of the linked list, it uses the double linked list data structure internally, and it can store duplicate elements. Also, it is not synchronized. So vector class in Java. Let me close this. So implement a global or dynamic array of objects similar to array. Vector contains components which can be accessed using an integer index. So index-based access is there in all the things. So it's only the thing is like it's a synchronized. So that is only the difference. So array list provides a random access. Okay, random. That's why the search is faster in array list. So in case of the linked list, so it does not provide the random access. So that's why the search is slower in this, but adding and deletion is very faster in this. So even like vector is also provides a random access. The search plays the better, but due to its synchronization, it cannot give the better performance. See, it is better in get and set means for the search options, array list is a better one. So for adding a removal, like linked list is a better choice. So I have this sheet, like most of the interviews will be asking the comparison actually. So the comparison between array list and linked list, when to choose which one, and also a comparison between array list and vector, when to choose what. So I prepared some sheet actually. So to give the more clarity and like all these things. So these are all about like list implementing classes in Java collection API. So any doubts in today's topic?
Actually, in collections, like we have hash map, that and all, it's very important. Is it?
Sorry,
Like in collections, we have list set mapping.
map. Yes, yes.
Like maximum we are getting array list and linked list and hash map. Is it? Like I heard some.
No, generally like it
Oh.
goes like the comparison level. So
Okay.
you should know the features of the list. You should know
Yeah.
the features of the set. You should know the
Okay.
features of the map.
Yeah.
So within that, each
Okay.
category is there. So let's take a list supports the duplicates. Okay, what they will ask. So I'm having the requirement that so which supports the duplicates. So in case of the duplicate support, only list is only the option in the collection. So within that, which one you have to choose? So then the requirement will be, so in as per my requirement, I'll be having like more search operations, or else like more insert and deletions will be there. In such kind of requirements, which collection you will choose. So that's why like, so duplicates in the sense, only the list is only the option, because set and map are like, no, does not allow duplicates. Okay, then the next requirement is, so if it is a more search based, means getter and setters are there, I'll go for the array list. Okay, that gives a better performance for that. And instead that I'm having more inserts and deletions, right? So in such cases, I will go for the linked list because that gives a better performance for me. So like this, within this also, like I need to allow duplicate elements and I don't want to support multi-threaded environment. So in such cases, what you do, you will go for the vector. Like this, the questions will be there and the requirements will be chosen like this. Okay. So similarly, we'll go through for other interfaces also in the coming sessions. Chandrasekhar, can you stop the recording?